We're going to calculate the derivative of the logarithm here. And the way we're going to do it is with implicit differentiation, which we've seen before gives us access to finding derivatives of inverse functions. And since the logarithm is the inverse of the exponential, base a, then we can use implicit differentiation to calculate the derivative that way. So what we're going to do is we're going to set y equal to log base a of x, and that is equivalent to saying that a to the y is equal to x. That's the inverse relationship between logarithm and exponential base a. And then we're going to differentiate this implicitly. So when we do that, we're differentiating both sides with respect to x, keeping in mind that y is a function of x. So we're going to need the chain rule on the left-hand side of this equation. So the left side, the derivative of the exponential base a is itself times the natural log of a. A to the y times the natural log of a. But then I have to also multiply by the derivative of y with respect to x. And that is basically using the chain rule. And on the right-hand side, we have 1. So solving for dy dx here, we have dy dx is 1 divided by a to the y times the natural log of a. And now we use the fact that a to the y is equal to x. And so we have dy dx is equal to 1 over x times natural log of a. Okay, so this gives us that the derivative with respect to x of the log base a of x is equal to 1 over x times the natural log of a. And in fact, since the base e is sort of, well, we call it our natural log for a reason, but this the base e is sort of the natural exponential, and also the base e is the natural log, it's worth kind of just seeing that the derivative with respect to x of the natural log of x, since the natural log of e is 1, it's just 1 over x. Now, the one next thing here is it's worth kind of noting that the domain of the natural log is positive real numbers. And so this only gives us like 1 over x for the positive real numbers. But at some point, and this is going to become more important later on when we start talking about antiderivatives, that is kind of given a function, asking the question, is this the derivative of some other function? Okay, kind of going backwards. What function has this as its derivative? In that case, 1 over x has a domain that is all real numbers except for 0. So all of the positive real numbers and all of the negative real numbers. And so we might want to ask ourselves, is there something that we can get that is more expanded than the natural log of x, that has a more expanded domain that has this as its derivative? And it turns out that basically, if I was to, the domain of the natural log is like, we have to have positive real numbers. So what if I wanted to put a negative real number in there? Well, the most naive thing that we could try is just take the absolute value of the x and then take the natural log of it. So there's this question of like, what is the derivative of the natural log of the absolute value of x? So let's ask that question. And so natural log of the absolute value of x, well, the absolute value of x is either x if x is greater than 0. And I'm not going to say greater than or equal to because we can't put 0 into the natural log. So the absolute value of x is x if x is positive, and the opposite of x, which is a positive number, if x is negative. And so we would be taking the natural log of that number. So that's the natural log of the absolute value of x. And we've already seen that the derivative of the natural log of x is 1 over x for x positive. So now let's calculate what is the derivative of the natural log of negative x for x negative. And for this, we use the chain rule. What I'm going to do is I'm going to take 1 over that input to the natural log function times the derivative of that input, where that input is negative x. And so this is 1 over negative x times the derivative of negative x is negative 1. So it's 1 over x. Oh, this is so beautiful. So we found that the derivative of the natural log of negative x is also 1 over x if x is negative. So when we broke this up into two pieces, in both of those pieces, the derivative was 1 over x. So that tells us that the derivative of the natural log of the absolute value of x is actually just 1 over x. And thinking about this, the natural log function looks like this. It's like the, remember, you kind of think about the, this is the inverse of the exponential function. This crosses at 1, 0. And if I want to take the graph of the natural log of the absolute value, well, what would the natural log of the absolute value of negative 1 be? Well, it's the same as the natural log of 1. And like anytime I have one of these x values, I just go over to the other side to read the y value. So it's going to be reflected across the y-axis. So this is y equals natural log of the absolute value of x. And thinking about what what 1 over x looks like, 1 over x looks like this. And so we see on the right side with the regular natural log of x, the function is always increasing, so the derivative should be positive. And closer to 0, the graph is steeper, so the derivative should be a bigger number. And then for larger values of x, the graph is much less steep, so the derivative should be a number that's closer to 0. And on the other side, for negative values of x, it's exactly the same shape, except the function is decreasing rather than increasing, so the derivative should be negative. So again, we see this symmetry of the derivative reflecting the symmetry of the original function. And I don't remember if I've mentioned before, but there is this connection between, like, if your original function is even, then the derivative of that function should be odd, and vice versa. So this is y equals 1 over x. And there we go. So things to remember: the derivative of the log base a, and I'm going to say of the absolute value of x, so we can expand the domain of that log function, is going to be 1 over x times the natural log of a. And specifically, if a is e, the derivative of the natural log of absolute value of x is equal to 1 over x. And this contains in it also the fact that if you don't have that absolute value, then you're just looking at the derivative of the function where x is restricted to be positive numbers, and the derivative is going to be the same, but that derivative is going to have only positive number outputs.